Hello and welcome. As a part of my series Infrared Ground Telescopes, I wanted to talk about the 3.6 meter ESO telescope. You may wonder if this is an infrared telescope at all, and of course it's also working in the visible range. But I wanted to mention it also because I love this telescope and also because of the history of the big observatories in Chile and ESO in particular. As you can see, it's a very characteristic building because you have a large cupola and a small cupola, which is for the CUDE auxiliary telescope CAT. That's a smaller telescope that can be used together with the 3.6 meter or separate from the 3.6 meter. That's, by the way, not my term for it. The people just call it the 3.6 meter. Here is again the outline of the presentation. History and purpose, motivation, with this time with emphasis on the history. Equipment, although I can't say much about the past equipment, just about the present one. Then geography, which is very nice to see it exemplarily with all these big observatories that are along the coastline of Chile. And not many results, just a couple of pictures and then a little outlook. So this is how it was built. The 3.6 meter telescope. It was one of the first, and especially the first large telescope of ESO. And ESO was founded in 1969 with 6 member states. Although I'm not sure if it was actually more, because Scandinavia was more or less pulled as a member state in the description. And first the idea was to copy Lick's 3 meter Shane telescope and put it up there. And then later people realized that you can't really copy a large telescope because the telescope and the place it's going to be build a unity, and not each telescope fits on every mountain. And then there were some hassles with who is gonna plan the telescope, and it was first they chose a too small company that couldn't really finish the concept, this kind of thing. And then still they managed to build it, but I will tell you later some of the tweaks that played into it, because ESO was still a quite new organization, not very powerful, and it needed some help. And it got some help. But this is how they built it, and on the left picture you see the cupola of a smaller telescope, which is the Danish 1.54 meter telescope, which obviously was finished first. And in the background you see the cupola, the not finished cupola of the 3.6 meters. And as I told you, it's a 3.6 meters telescope. It's made of fused silica, and the mirror was made in the US by Cornish, and then it was brought back to Europe, and then only then people figured out how to build the telescope around the mirror, which then took quite a while. But in the end it was a telescope, a Cassegrain telescope that could also be used in prime focus, and had even a longer f as a CUDE focus, so it was a f3, f8, f35 telescope. The actual instrument are harps and NIRPs, and you can hear already from the letters in the in this shortening of the sensors that they are somehow similar. The HARPS is the visible light counterpart, and the NIRPS is the near infrared counterpart of basically the same thing. So the main purpose is spectroscopy, and the spectroscopy is used to find wobble in nearby stars to find planets, extrasolar planets. And obviously this is done both in the visible part and in the near infrared part of the spectrum. And here you also can see the mechanical build-up of the telescope. It's this U-shaped mount, and obviously very heavy. And there are the commissioned instruments, a spectrograph and another spectrograph for faint objects. And then there was the TIMI-2, which is a long-wave infrared camera from 3 to 25 microns. So obviously in the past also long-wave infrared has been observed with the 3.6 meter. And here the fun fact I already mentioned one slide before. At some stage CERN helped a lot with office space and logistics, and also with engineering to get the 3.6 meter finished, which was very crucial for ESO, because without this telescope ESO wouldn't be ESO, but just a collection of smaller national telescope on a mountain. And history later took on drive a lot, which I will show later. Then the geography. As I told you, from the air it's very easy to spot a 3.6 meter because it has two cupolas that are connected here. And that's the old version of this kind of telescope, whereas just left to it is the NTT, the new technology telescope, which uses active and adaptive optics, whereas active optics was tried out already in the 3.6 meters. But the NTT then is the consequent implementation of active and adaptive optics. I won't talk much about the NTT, but it's an important step from the 3.6 meter to the very large telescope, which was built later. So NTT was to try out, and they have almost the same size and they're on the same hill, which is funny. And then if you look at this coast of Chile, there are so many. Here is the La Silla Observatory where the 3.6 meter is, so quite a bit south. And there is also, for example, the Cerro Tololo Inter-American Observatory, then the Las Campanas Observatory. These are the two American ones, US American ones. And then, or US America founded ones. And then quite a bit further north there are the VLT site and the site for the extremely large telescope ELT. And funnily, if you're in space, you can just look for this little mushroom here, and then you find these two observatories. So I think no country in the world has so many large observatories as Chile does. And it's a good thing that Chile is also proud of that and also makes sure that the conditions stay good for this observing in Chile. But ESO was one of the pioneering large observatories in Chile. And then I just give some example results that I found, not so many. Here, actually the 3.6 meter telescope discovered a moon of Saturn, here called 1995 S6. That's the way you number new planetary moons, and Saturn, each year new moons of Saturn are discovered, so that's why it has so many moons. But back in 1995, not so many moons were discovered, but the reason this moon was discovered in 1995 was because you could see the rings from the edge, and this makes it easier to spot moons. And the inner moons are, as always with planetary rings, tightly connected to the rings. So the way the rings are structured is given by the small moons around the rings. And for Saturn, of course, the ring system is an ecology in itself, because many funny things happens there, like two moons having the same trajectory and swapping the place they are, this kind of thing. Very interesting. It's also a good model for a solar system. Then there's a picture of the irregular galaxy NGC 55, and this is just a very lovely picture. Reminds a bit of the Whale galaxy. And this galaxy is close to the Sculptor group, but it's actually not part of the Sculptor group, but of our local group of galaxies, and not very well known for that. Just an example picture, probably from back in the days when 3.6 did more imaging. And of course, lots and lots of observations of planets, but they're spectroscopy and not very imaging bound. So lots of these things I told already. It was ESO's first large telescope, and also good basis for experimenting with kits, sensors and things for the and better focusing, this kind of thing. How can we get rid of the seeing to greatly improve the resolution of the pictures? It was a very important telescope for that. And it paved the path for the NTT I already mentioned, and later the VLT, and now the ELT that is gonna be finished in a couple of years. And now it's dedicated to measurements in exoplanets in other solar systems. And here in the end I also have a very, very lovely picture of galaxies that 3.6 made, and another view of the cupoles. Thanks a lot for the attention.